Hello everyone, I'm Steve Smith and I'm going to talk about the DevOps continuous integration. Who am I? I'm an Agile and Continuous Delivery Consultant. I'm co-organiser continuous delivery events, and I'm the co-author of a book on continuous delivery stories, including stories from the likes of Alex and Rudy and Dave Fowler of the forward. If you use that discount code there, you can get I think 20% off. And my company does continuous delivery training courses and continuous delivery consultancy. We're affiliated with Legal Experts, which basically means we're part of a network of independent software experts. And if you like Sunshine, they've got office in Lisbon now. So, okay, I'd like to start with the thing that's of value. The thing that's of value is what customers want. And the way we learn what customers want is we adopt continuous delivery. Continuous delivery is really important because it is a holistic method of reducing your time to market. And as Dave mentioned in his keynote today, when you reduce your time to market, you can run experiments, you can learn faster, and you can grow product revenues as a result. But what Dave didn't mention is that continuous delivery is really, really hard. Okay, it's not easy for any number of reasons. It places demands upon you in terms of people and technology. And one of the demands in terms of technology is that the code base has to be reducible on demand. And this is something that's often overlooked. If you're going to have shorter lead times, you need to be able to release whenever you want. To be able to release whenever you want, the code base has to be releasable. And that's where continuous integration comes in. Continuous integration gives you a code base that's always iterated, always tested, and always releasable. And it's for that reason that continuous delivery is heavily dependent upon continuous integration. And David just mentioned it many times in the book, and they've got a great quote where they say that the deployment pipeline pattern is a logical extension of continuous integration. It's taken to its extreme form, which is continuously integrating production whenever you wish. So that's all really good. And continuous integration itself is not a tool, it's not Jenkins. I don't care how nice your continuous builds there is, it's not continuous integration in its own right. Continuous integration is a shared mindset of collaboration that's verified by a tool like Jenkins or like Travis. And Martin Fowler originally defined continuous integration as a mindset in which every member of the team integrates frequently, and usually each member of the team integrates at least once a day. So we're talking about a mindset where every developer on a team commits to the trunk at least once a day. And an individual doesn't practice continuous integration, the team practices continuous integration. If one member of your team is not committing to trunk every day, the team as a whole is not practicing continuous integration. You're not getting feedback on everyone's in-flight changes at any given time. Your code base is not always usable. So that's a very high entry barrier, and it's often understated how high it is to get everyone committed to trunk on a daily basis. But when you do have that, there's a whole raft of benefits waiting for you. You have a very small change set size globally, which means that merge conflicts and test failures can be resolved very quickly. And you have a much more predictable flow of features through a team, and that means that you can have more adaptive release scheduling. And kind of as a corollary to Martin's work on continuous integration, a guy called Jim Shaw wrote a really good book about XP in 2007, I think, called The Art of Agile Development. And in it, he talked about builds being monitored synchronously and asynchronously, with synchronous integration being where the developer commits their changes to trunk, waits for the build to pass, and then moves on to the next task. And with asynchronous integration, the developer will commit their changes to the trunk and then immediately move on to the next task before they wait for the build to finish. Now, asynchronous integration feels like it should be more efficient, but Jim made a very specific case I entirely agree with, that when you asynchronously monitor builds, it will lead to slower and more broken builds over time. And that's because if I'm working synchronously, if I'm committing my change to the trunk, and then I'm monitoring the build before it completes, then if the build is becoming slower, I'm going to feel the pain of that slowdown. I'm going to feel completely abusive about it, because part of my working day is spent waiting for something to finish and it's getting slower. And if the build is broken in that situation, then I have all the necessary context in my head to fix it immediately, because of the last thing on the work time. If I'm working asynchronously, then I'm not going to feel the pain of a build that's slowing down, because it's not actually impacting me and my work every day. And if the build is broken, it's going to take me longer to fix it, because I have to interrupt the flow of my new task and switch back to my old task in order to resolve that problem. Okay? So let's have a show of hands. So based on that, so how many people are working on a team today where everyone commits to trunk on at least a daily basis? Okay. Okay, now put your hand down if you like. Oh, okay, that was a test. Okay, so keep your hands up please if your build is less than 10 minutes. Okay, and keep your hand up if builds are broken for less than 10 minutes. Okay, very nice. Okay, so I thought Unruly would be one of the few hands left because I thought Unruly are awesome, and there's a few others as well. But there weren't many hands there, were there? How many people they would have put their hand up if I said, put your hand up if the whole team were committing to Jenkins? Or, you know, using Travis, and probably a lot more people. Thank you for your honesty, sir. It's very nice. I feel exactly the same way as you. I currently work on a team where, you know, we're committing to trunk most days, but sometimes we're not, and we'll get to that in a little while. I contend that continuous integration is by far the most valuable practice in the Agile Count. I don't say that lightly. And I also believe it's the most imperiled practice. I think that continuous integration has been on the decline for maybe 5 or 10 years now. And I've got a theoretical argument to back it up. I've got some very colourful constructive examples for you. And I've got a case study, me as a developer of the years I've worked in the industry. So we've got a limited data set, at least a data set that's going to tell you the truth. So why don't we start with me starting. And when I first started in software development in the early 2000s, release feature branching was still kind of prevalent. And by that I mean the traditional form of feature branching. So feature branching is of course a practice where developers commit their changes to a branch of the source code repository prior to merging into trunk. And in its traditional form, that meant that you would have very long-lived branches. Developers would develop entire epics on a branch, not just features. And you might have done this with ClearCase. It really advocated this model in the early 90s. You might have done it with Subversion or Perforce or a really awful tool called MKS that I was longer with. And the way it would work is developers would make their changes on their branch, the testers would test on the branch, you'd have a production release, and then eventually you would merge back into trunk. That would be very infrequent, it would be messy, it would be complex, time-consuming, and unpredictable. And then you'd also have a regression test on trunk, of course, unless you're a real glutton for production defects, and because trunk would be so different from the branch that you'd be working on. So I worked at a company, a little telco, in the mid-2000s, where we had release feature branching, and it was kind of similar to this. So in this example, at least which is entirely contrived, we have a company account service team, and we've got 4 different epics that happened over a period of months. Corporation tax, trading losses, statutory loans, and participator loans. You don't have to understand what those are, I certainly don't. And in each situation, developers are making lots of changes on the branch, testing happens on the branch, maybe there are some build failures, doesn't really matter, does it, because you're not affecting anyone else, something new. And then eventually, there's a merge back into trunk that's going to be pretty horrific. And yes, you might do promiscuous integration, as we know as here. Any experienced developer will do that. You'll be constantly putting the latest changes into your own branch to reduce the eventual complexity of your merge back into trunk. But you'll never get away from the fact that you need that regression testing overhead, which remains as unpredictable and as time-consuming as ever. So here we've got our 4 features, and we've got 10 production releases happening, and then we have some production defects fixed later on by resurrecting dormant branches. That was always horrible because then the branch was really, really out of date. And the only really good thing you can say about this way of working is that when a different branch is broken, you don't care. You're absolutely fine and entirely divorced from that problem. And I did this for 2 years at a company, and I worked on the Hungary branch for 5 months of my life. So I would make my changes for Hungary, and my colleague might be working on the Netherlands, so don't worry about that, that's his problem. So I'd be working on my branch, testing would happen on my branch, and then eventually after release we'd merge into trunk. And I might have one of my peers working in the Czech Republic branch, I might have another working on the Poland branch. Okay? And you spend all of your time merging between branches, you don't have a lot of time to actually work on new stuff. You don't do any opportunistic refactoring, you don't fix any broken windows out of self-preservation, because you know that every file you touch increases your change set size, and the larger the change set, the greater the probability that you're going to have a really messy merge weeks or maybe even months further down the line. And there's also, as I mentioned, not a lot of collaboration here, because 2 different people on 2 different branches are going to diverge in 2 different directions. That's because of Conway's law. So the longer those changes are apart, the more radically they can move in different directions. And the code base will gradually deteriorate as a result, because there isn't a cohesive vision for the direction in which we want to take the code base. So, is this compatible with continuous integration? God no. It's utterly impossible to do continuous integration in this old school world of feature management, okay? And after 2 years of doing this, I read about Agile and continuous integration, and I actually quit the company for a place that said they did continuous integration for real. So the way that continuous integration used to and still does happen is with trunk-based development. So trunk-based development sounds quite scary, but it's actually lovely. And you might deal with a centralized version control system like Perforce or Subversion. You might deal with a distributed version control system like Git or Mercurial. I've done it with both many times. And the way it works is developers directly commit their changes onto trunk with minimal branching. That doesn't mean zero branching, it means just avoid it wherever possible. You think much more about the design of your code base rather than the design of your branches. So here we have our company account service team again, and let's zoom in on a period of days or weeks rather than months. And we can see here we've got two different features in flight on trunk, computations and write-offs. And again, don't worry what they are, I know what computations are, they know what write-offs are. When two features are happening at the same time in trunk-based development, the developers are compelled to talk together. They have to figure out the design together, it can't be avoided. And what will happen probably is that at least one of those features will be concealed for a period of time until it's ready to go into production, and will normally conceal the larger, more complex change. Anyone know how you might do that?
With a toggle?
Thank you. Yes. The one person in the room that's friends with me. Yes, it also says toggle on the diagram, so you can that's good. So you and I are going to hang out this, you can read and we're friends. Thank you. So everyone's basically Dave's keynote and they're still mesmerised by all of the flashing lights. Yeah. So yes, a feature toggle is basically where you use runtime configuration to conceal a feature until you're ready to use it. It doesn't mean you literally activate those things, which always makes me really sad. It just means you flip something off at runtime until you're ready to use it. So in this case, let's say that our team conceal computations. Next up, write-offs feature is being finished. It's already on trunk, there's no merge. The testers test it on trunk, and then we can have our production release. We start two more features, bank details and account periods. Let's say that account periods is a much more complex change, involves a third party. And in this case, we need to make some updates to existing behavior. And that needs to be concealed. Does anyone know how we might do that? It's not with a feature toggle. And yes, it's on the diagram. So the one guy who can read is going to tell me yes. Unless you can't read it, it's not. Yes, it's a branch by abstraction. So you use branch by abstraction to conceal updates to existing behavior. And you do that by introducing a layering direction in the code that hides away the new feature, the changes to the code base until you're ready to flip over to them. So now we're in a situation where our build is testing with computations toggled off and the account periods branch by abstraction, serving up the existing behavior. And if we want to, we can run our automated tests in both modes if we wish. And that, by doing that, we can verify that these features work together when they're turned off and when they're turned on. So that's the way that we get complete confidence that our code base is always integrated and always tested and therefore always reusable. So next, let's say there's a production defect in our write-offs feature. So what will happen is it'll be fixed on trunk. Let's say that for risk mitigation purposes, we agree that we need a branch. So we create a branch just for that defect fix. We merge the fix into the branch, and then that branch terminates after the production release. Bank details feature finishes, so that can be tested on trunk and released into production. But just before that, of course, we've had a build failure. So with trunk-based development, build failures are a really big deal. You can't hide from it. It affects the entire team. When the entire team are committing to trunk multiple times a day and resyncing from trunk multiple times a day, a build failure really annoys people. And that means it's an opportunity for the team to learn, to maybe spin around their chairs and talk together about how that situation could be avoided in the future. It's not something that can just be hidden under the carpet and forgotten about. So finally, our computations feature is deemed complete. So we toggle it on in production, which doesn't involve production release because the feature is already there, we just have to flip it on. And let's say also that our account periods feature is deemed complete, so we turn our branch by abstraction on, and we flip it to point at the new behavior rather than that legacy submission system behavior. So, and let's say now there's a production defect in that account period, in that new account period behavior that's blamed on the third-party system. That's what we want. And in that case, that's no problem. We can just flip it back within seconds to that old legacy behavior which might be in place for a couple of weeks, but it's very easy. And we know that everything is still going to work together because it's always worked together, it's always been building together, it's always been tested together. So we have complete confidence in this situation that if there's a defect, we can respond very quickly to it. So clearly, in this example, these features and the team itself benefit from working together in a single shared code stream. In the case of the feature toggle and the branch by abstraction, the entire team understand the why and the how, so everyone will be able to contribute to it if they wish. The team understand why a release branch is necessary and how it's being used. And the entire team are aware that there's been a build failure in a particular area of the code base, so people will be more aware of it, and people will work together to try and resolve similar situations in the future. Everyone working together on a single code stream means that opportunistic refactorings can be worked on all the time because you know that you've got a very small change size and you can code. There'll be a high degree of collaboration because everyone's always committed to trunk, so changes are always being announced to you effectively. You can see where people are in the code base and you can go and help them in an area that you're familiar with, and you can talk to them if they're approaching an area that you're currently working in. And everyone is also in a position where they are working together on a single cohesive evolutionary architecture. The code base won't decline in quality because there's a shared vision that everyone is working towards one commit at a time. And also, you can massively de-risk releases and make money by doing feature toggles and branch by abstractions because they have operational and business benefits. So we might use a feature toggle to gradually turn on a feature one server at a time to make sure it's performant. That's a technique known as canary releases. I work with a guy in a RevOps team who insists that every feature is now behind a toggle so he can turn them on or off if he wants to. Everyone thinks he's mad. I love him. I think he's brilliant. And also, as I said, there are business benefits to feature toggles. You might actually choose to launch a feature to a specific demographic of users before you give it to your entire user base so you can get fast feedback from a minority of people. Or you might also choose to line up a number of features to all be turned on at exactly the same time to mimic a big bang for marketing reasons, without the awful big bang of the code being released, of course. Okay? So, cohesive architecture, everyone's friends, and you de-risk operational releases, and you also empower your business stakeholders to choose when features are actually turned on. And that's really, really good, because then people stop arguing about when something's going to be released, and business people argue amongst themselves about when to turn something on, and you can go on and do something else. Oh, and did I mention this is obviously entirely compatible with continuous integration, because when everyone is individually practicing trumpet development, automatically reach continuous integration. So this is all really good. I'm selling it quite hard because I don't know what teams doing. But again, I'm not going to pretend that this is easy. Trunk-based development is simple, but it is not easy. It requires an investment from individuals and investment from the team in development practices and automated testing. Every day, every individual on the team has to replan, redesign, re-architect the system. It requires constant ingenuity from everyone on the team. If you have a legacy code base, it can also be much more difficult. But it is a really effective way of working that brings you towards continuous integration and continuous delivery. So there is one interesting point about trunk-based development, which a lot of people comment upon, is that it, a bit like test-driven development and other good practices from XP, feels like we're going slower. Features will take longer to reach develop complete with trunk-based development, and then your velocity might drop, and then your Scrum Master might feel sad, and then we can't have that coming. At least not for too long. But that's because velocity is rubbish. Velocity is just a localized metric. What you want is a global metric, like cycles now. And when you concentrate upon the time it takes to get from idea to customer, or even just from developer to customer, you'll find that trunk-based development is superior because it ensures that the whole team works at the maximum rate of the team, rather than at the rate of the fastest individual. So that will dramatically reduce the amount of rework in the code base. Okay? So I did this, as I said, for 7 years at a bunch of different companies, including for 2.5 years with PayFire and a bunch of other smart people at Elmex. And that was actually with Subversion. So that all worked really well, but you can actually learn more about this from a really good story, which is the HP story. So how many people here have read A Practical Approach to Large-Scale Agile, the HP book, the blue one? You have. Good. continuous delivery training courses, I recommend this book to people before I recommend Dave's CD book. Sorry. But the reason for that is Dave's book has all of the theory, which is really important, but people, in my experience, learn best from stories, and this is a really, really compelling story. So this is about the HP FutureSmart program, the firmware that powers HP scanners, copiers, and printers. And in 2008, HP were in dire straits. They had 400 engineers worldwide on 10 million lines of firmware, and they had multiple different product variants on different long-lived release feature branches. And as a result of that, they had a 1-week build, they had a 6-week manual regression testing cycle. I think at their absolute worst point, they had a 2-year lead time to get the features out the door. And there's a clue in it here. They found that their engineers spent 25% of their time on product support, which is a polite way of saying the developers are constantly merging features between branches to try and keep product owners. And only 5% of their time was actually available to work on new features. This is exactly why they ground to a halt. Okay? Because they were working in a way that simply wasn't sustainable. So they got over this in, I believe, just under 4 years by making a massive investment in continuous integration. First of all, they made a really important business decision that every device worldwide would get a different version of exactly the same product. They extracted the product rules from each of the different release feature branches and turned them into runtime configuration. So then when a copier or scanner or printer started up, it would say, I'm a copier, and then it would receive different runtime rules to apply to exactly the same product as everything else. Everyone was moved on to a single code stream, which I believe was Git. Everyone worldwide was given exactly the same development workstation, VM, and they did a whole bunch of other cool stuff. But after a couple of years, it meant that they were down from a 1-week build to a 3-hour build. They were down from a 6-week manual regression testing cycle to a 24-hour automated testing cycle. They built a really awesome, custom-made, automated build set. They did all kinds of cool stuff with testing. I think it had like 5 different stages, and the final stage actually printed a page out of the printer, which is pretty cool. But when they got to this point where they could produce 10 to 15 builds a day rather than 1 build a week, it completely changed their business. And instead of being considered a cost center, the technology division worked in partnership with the marketing division. And the engineers then spent 40% of their time on new features rather than 5%. So that's an 8-fold increase in productivity for 400 developers. There's not a CTO alone that wouldn't want that. And Gary Gruber, Mike and Pat Ford, and the authors of the book have a really great quote. They say that continuous integration and quality are everything together and nothing without each other. So you can't have one without the other, which is really interesting thing to think about. And that's where the story ends, at least if this was 2008. But obviously since then, we have the rise of distributed version control systems, which is a really good thing because they're awesome. You know, I use it every day. I've used it for a couple of years now, non-stop, and it gives you all kinds of cool stuff that you need and some stuff you don't need. But you know, just the ability to do offline commits is absolutely brilliant. You know, it used to be a nightmare doing it with a centralized version control system; just wasn't possible. But what it does mean now is that I think we need to kind of look at these more lightweight versions of feature branching that are very common, and try to understand the extent to which they are compatible with continuous integration. I'm not interested in an overly emotive debate about tools. I'm interested in looking at where continuous integration is and isn't possible and kind of understanding the trade-offs around that. So let's not waste our time talking about some of the crazier version control strategies that are out there these days. Let's focus in on the really interesting one, which I think a lot of people here will be doing, which is build feature branching. So by build feature branching, I mean a situation in which you're working on a team and everyone develops features on very short feature branches. They last for a day or under ideally before you merge back into trunk. You test the tests on trunk, and then you release that into production. So you might be doing that with a Fury or Git or GitHub. This is what GitHub Flow is essentially. It's what GitHub are themselves. And you might kind of develop Subversion back in the day, although likely the expensive creative branches dissuaded you from doing it. Anyone else here working this way? I'm certainly out at the moment. Yes, quite a few people. How many people, keep your hands up please, for doing this with GitHub? Yeah, lots. GitHub's awesome, isn't it? There's so much cool stuff. I've got the permissions model turned on now in my GitHub. It's really exciting. I'm so nerdy about it. So that's all really lovely. So let's return back to our company account service team, and let's consider the same kind of time period and the same features, but with build feature branching rather than trunk-based development. So let's say that computations and write-offs features start on our short feature branches that the tenders last for a day. Next up, our write-offs feature is deemed finished, and then it's probably going to be reviewed before it's merged back into trunk. We might do that with something like a GitHub pull request. And the merge state is going to be very low because you've only been on a branch for a day, and there's no regression testing overhead, which is great because that was awful in previous incarnations of feature branching. A computations feature, let's say that it's grown to encompass a refactoring, so it's going to take a little bit longer. There's been a build playlist, it's going to take time to unpick. But we also start up our bank details and our account periods features on their own branches. And then let's say that we have, again, our production defect with write-offs, so that will be fixed on its own feature branch, and after the production release, that will be merged back into trunk. We have promiscuous merging because any sane developer does promiscuous merging, but pull the latest change from trunk into our branch to, again, minimize our own final merge. Our bank details feature finishes. It's reviewed by a non-bank details developer, and that's merged into trunk and released into production. And with account periods, that's going to last a little bit longer. Let's say that that's got a build failure with that submission system that I invented. And finally, our computations feature and our account periods feature finish, and they're reviewed and then merged into trunk. That's probably going to be quite an involved review process, I'm guessing, because it lasted for a while. And then we have that production defect again in our account periods. So we might have a fixed on its own branch and merged back in. Is this way of working familiar to people? Certainly familiar to me, although I did think it's that. So this is a really, really good way of working. Because the tool is so nice, you just push a button and it just does stuff. You don't have to think about anything abstract, especially abstract away Git, which is lovely. You know, Git is like a, I can't remember if it wasn't said, it's like a Swiss Army knife of time machines. You know, anything. But you know, with GitHub on top of it, it's really, really nice. It works really well. But for me, you know, there's a bit of a problem here. I mean, yes, you've got your minimal merge complexity, you've got no regression testing overhead. My beef with this is that I believe that this way of working is probably incompatible with continuous integration. But before we'll reach our pitchforks, which is very easy because we're in core one, pitchforks are always within arm's reach. I can say this on top of I'd say anyway. I have a number of reasons why I believe this is the case. So for the last year, I've been working on a project with 30 teams around the country, and all of those teams are practicing build feature branching. And I know that because I check up and I'll make sure the other will get on flow, because there's a lot of crazy stuff out there. And a couple of teams are practicing continuous integration. One team in particular, which is why I was asking about Charlotte, she was on that team until recently. That team, you know, they're pairing, they've got very small features. Every person on the team is merging to trunk at least daily. You know, everything's working really well for them. Although interestingly, they do skip pull requests, they merge straight into trunk. And meanwhile, the team that I initially started on a year ago really struggled to get it all right. You know, on my first day, I remember, you know, I made my changes, I finished my work, and I turned to the person next to me and said, you know, great, where do I find a build server to watch my build? And she said, before that, raise a pull request and put it into the chat room, and then one of us will review it for you, and you know, then we'll merge it in for you. Is that something familiar to anyone? Pull requests and chat rooms? Not? Okay, good, I'm not alone. So, you know, I remember saying at the time, you know, that's brilliant. Why are we going slower than we need to go? Which got me into trouble. You need to keep your mouth shut on day one of a new project, which I never listened to. So, that one team was doing really, really well, but I could see my own team was struggling a little bit, although I should say it's massively improved over the past year, possibly because I left the team. So I was speaking to the team lead of the team did really, really well one day on the walk back to the station. And I said to him, so you've got your short-lived feature branches, and then you're merging directly into trunk. You know, you're working really well together, very small features, everyone's committed to trunk daily. Why not just go straight to trunk-based development now? Because surely that branch is just getting in the way. And he turned to me very politely, and he said in quite a kind of confused, hurt voice, why would I do that? And then I got confused and I got hurt, and I did what I always do. I went home and I moaned to my wife, and I wrote a load of blog posts and I did a lot of thinking. I watched some videos, and I spoke to Jez about it, and Jez just said trunk-based development is lovely, which wasn't terribly helpful. And then I spoke to guys and all about branching, and I made Dave on a video call with him for me, and Dave just got angry, and that wasn't terribly helpful either. And then eventually I did come to an answer which I'll share with you at the end. it took some time for me to realise that this guy had simply never done truck-based development. You know, he was more experienced than me, he's been around for quite a while. But he'd always done different variants of feature branching. Now he had a way of doing it with a tool that was so good, his team were doing it all really, really well. But his team were all experts. They were all very, very experienced developers. They'd worked on the project for a long time. They'd been a team together for a long time. Okay? And they knew to go against the grain. I think that there are a number of fundamental assumptions with this way of working that often break down. So if we look at the interactions involved in build feature branching, so there's a developer, she makes her changes, she fits them to her branch, and then she asks for a review. The reviewer reviews the changes, the reviewer clicks on the trunk, there's a build triggered, there's feedback to the original developer, and everyone's happy, and there's bunnies and meadows. Everything's fine. The problem is that this is often a fantasy. This doesn't happen. I think that there are a number of really key assumptions here that simply don't hold up most days of the week. Number one, that the feature branches will always be short-lived. Number two, that reviews will always be timely. And number three, that builds will always be well monitored. So let's look at each of those. So first of all, the idea that feature branches will always be short-lived is very problematic. Feature branches won't look like that. They'll look like this. There'll be a whole bunch of commits. The branch will last longer than a day. And that's because feature branch duration is only limited by developer discipline. And all too easily that can be lost, even with the best of intentions. And I'm as guilty of it as anyone else. Okay? You start working on something at 9 a.m. intending to have it in trunk by the end of the day. At 2 p.m. you pick up a refactoring. 4 p.m. you've got a meeting. 5 p.m. you say you pick up a UI tweak for someone. The following morning you're off working on something else, helping someone else. And before you know it, it's been a day or 2 days or 3 days. Your branch is growing stale. Your merge complexity is increasing. And no one else has had feedback on how your changes integrate with the rest of the system. I think that happens very often. And it's easy to find out because don't just listen to me, measure it, as Dave said in his keynote, okay? Measure the duration of time your feature branches last. And I suspect the median duration will be greater than the day. I know it is on my project because I've measured it. Okay, so our second assumption is that reviews are always timely. Anyone fallen into this trap before? You know, you ask for a review for your work and it doesn't happen for a day or so and you're off working on something else. So this happens because reviewers are not just sat around waiting for you to finish what you're working on. They're working on their own stuff. Right? So what will happen is the review process won't look like this. It will look much more like this, where the developer asks for a review and then they wait for the reviewer. The reviewer comes along and asks questions about the feature that they aren't familiar with, and they wait for the developer to answer. The developer answers the questions and they wait for the reviewer to come back and do the review. The reviewer does the review and then has some feedback they want the developer to work on. So then the developer, okay, lost which one am I now? The developer line. So the developer makes the changes, commits them to the branch and asks for a re-review. Then they wait for the reviewer. The reviewer eventually comes along, accepts the changes, merges them into trunk, triggers the build. The developer finds out everything worked, and everyone's a little bit happy. The problem with this process is that a review is composed of multiple handovers between two different people, and each of those handovers is an opportunity for delays to creep into your value stream. Reviews can take a day, 2 days, very easily, just because the right person wasn't available at the right time. It happened to me last week. I took Friday off to go to a wedding, and then someone said to someone, "Oh, wait for Steve to get back to work on that." You know, because that's Steve's thing. I got back and I was really cross. Like, why did you wait for me? Do it without me. Okay, I'm not the right person. I'm not there at the right time. Don't wait. Okay. I think this happens quite often, and on my project I've measured the amount of time the review process takes between somebody being committed onto the branch and then actually merging into master. It creeps over a day very, very easily. Okay? You might think that it's going to be a very quick process, but it isn't. And that, of course, isn't even taking into account the time it takes for the review to actually happen, someone to actually dig into the changes. So our final assumption is that builds are always going to be well monitored in this style of working. And I don't believe they are. I think that what happens more often than not is you get into that asynchronous integration way of working, which Jim Shaw warned us about over 10 years ago. What will happen is that when a build is broken, there's another handover. You have to wait for the developer. Because the developer has asked for a review on their original feature, and they've gone off to work on something else while they wait for the review to happen because the review is not timely. And then what happens is they don't feel the pain of the build getting slower. And when the build is broken, they have to interrupt their new work and come back and fix their old work. And then you get to really nasty vicious cycle where your build gets slower, so you run it locally less often, so then you have more defects in the build when you actually run it on the build server, so then you get a bit scared of running things on the build server. So then you start to build your branches on your build server to, protect trunk. And, that's lovely, you can do that if you want to, and I do it a little bit sometimes, but the problem is you're only getting feedback on how your changes work with the system that as it currently stands. It's nowhere near as good as continuous integration because you don't have feedback on how everyone's in-flight changes interact with one another. You don't know what other people have on their branches at any point in time. So then you're in a situation where your build is getting slow and your build is getting broken. That's how a 5-minute build becomes a 45-minute build. And that's not an exaggeration. There's a team I work with that used to have a 5-minute build, which was lovely. And then they came to me a while ago and said, how do we figure Jenkins to build our branches? And I was like, okay, you do this, you do that. Why do you want to do it? And they said, our build got slow. And we looked into it, and it happened because their feature branches were getting a little bit longer, because the review process was becoming a little bit less timely, so they were watching the build less often, and gradually their build ground to a halt. And when the build takes 45 minutes to run, it's going to take a lot of time to speed up again. So that team is in a lot of trouble, although they have done a lot of good work recently to sort it out. So 3 key assumptions that I think will happen to at least one individual on a team practicing build feature branching on any given day, in my opinion. I don't just have a theory on this, it's also based on my own practical experience, on my current project, and it's all because the tool is so nice, it just works. Back in the day, if you did build feature branching with Subversion, you'd be some kind of crazy person. Because of the expense of creating branches, it dissuaded you from doing this. It was so expensive to create branches, you would prefer to spend your time talking to people and actually designing changes that work well together on trunk, because you wanted to avoid creating yet another branch. Now, you just push a button and it just works. Okay? And all of us, me included, are moving to this way of working. In the Stack Overflow 2015 survey, I think 60% of developers worldwide were now using Git. Then they were closely followed by Subversion. Then they were followed by TFS. Would anyone like to guess the 4th most popular version control system?
CBS.
No.
Just
None. It's not just MKS.
Yeah.
Oh, you. None, correct. Again, yes, the answer was none. Higher than Mercurial, I have to write down. None. Oh dear. How big is that here? Anyway, yes. MKS now distracted me. You use MKS as well? Oh man. We're not talking later. Let's never talk about that. That was bad. Right, I'm going to stop thinking about that now. It's because that's distressing me. It's bringing back much back. Where were we? Yes, so now we're in a situation where GitHub is taking over the world. Everyone is on GitHub. It's due over the 21st century. And as GitHub gets more popular, and Git is, fantastic and obviously become more popular, we're being moved further and further in a direction that is probably not compatible with continuous integration. It's not the case that it can't happen. I've seen it happen. But it is unlikely to happen in my experience, unless you're a team of experts who know to keep the branches as small as possible, who know to do reviews very quickly or skip the review, and know to monitor the build. It's probably not going to lead to continuous integration if you're working in this way. Now, it does work really, really well if you don't need continuous integration. Let's be fair. So, if you have a team that's distributed all over the world, if you have a team where there are randomly different levels of expertise, both with IT as a whole or with the code base, then the need to mitigate those factors is going to be greater than the need for continuous integration. So maybe you're working on an open source project like Linux, let's say, where there are different contributors all over the world with very different skill sets that are working part-time on something. You don't need continuous integration there as much as you need a really sturdy review process. So people are on their own branches and people commit their changes into review, and then eventually the core team will merge into the main code stream. Okay, continuous integration is not as important. But then again, distributed version control systems were designed for open source development, and Git was specifically designed for Linux. I'm not surprised it works well in that situation. Okay? When you are a co-located team, when you are looking to establish continuous delivery for a prolonged period of time, so you have a strategic advantage over your competitors, this is absolutely not the way to work unless you are a highly experienced team who have worked together for a long time and know the code base intimately well. And I don't think that situation happens very often. I think that what we need to do is we need to reclaim continuous integration, we need to view build feature branching as an informed decision. If you don't need continuous integration, for example, people in different time zones or speak different languages or don't know the code base terribly well, then build feature branching could be a really, really good fit. But just because a tool makes it easy to create a branch doesn't mean you should create a branch. Tools should follow practices, practices shouldn't follow tools, and that's what really worries me. I worry about people that are new to a team, or new to a company, or new to IT in general, and they're just plonked in front of GitHub and they're told this does everything you need. Okay, that scares me quite a lot. What I'd like to see happen is for people to understand the values of extreme programming, the practices of extreme programming, the importance of continuous delivery and its roots in continuous integration, and the fact that build feature branching can be a really, really good stepping stone to trunk-based development. When you are doing trunk-based development, there's a really awesome way of doing code review that's continuous and has minimal rework. Does anyone know what that is? Yes, it's called pair programming. If two people actually work together all the time, then you're always reviewing work together. And if there is a problem, you can fix it on the spot, rather than a day or two later when a review actually happens. Okay? So rather than showing pull requests in the chat room, how about you actually turn to the person next to you and have a conversation with them like a human being, and actually talk about the design of what you're doing or what they're doing and how those changes might fit together, how you might test those changes together, how you might make an investment in the team and make an investment in trunk-based development. Okay? I'm not saying it's easy. Trunk-based development has a steep learning curve, and I think that the trunk-based development community has downplayed that in the past, which is unfortunate. It is really hard to do, but then continuous integration is hard and continuous delivery is hard. Okay? But just because something is hard, it doesn't mean you shouldn't try. And when you get to that point, there are huge benefits for your operations staff, for your business stakeholders, and for your developers, and for your testers. So I mentioned earlier, that I spoke to this team about a year ago, and he said to me famously, why would I want to do that? Why would I want to leave build feature branching for trunk-based development? And I really didn't know how to answer it succinctly because there was so much in my head. I just wanted to kind of splurge out on this poor guy. But I do have a decent answer now. I think for me, trunk-based development makes compulsory what is optional in build feature branching. It makes regular incremental commits to trunk compulsory, which means that you can facilitate continuous integration and you can drive the engine of continuous delivery. But continuous integration is done, make no mistake about it. It's not like TDD where, some people skipped about last year saying that TDD is dying. I see teams doing TDD all the time. I see very few teams doing continuous integration. There were a few hands up earlier. I'd like to see more hands up because this, for me, is the most valuable agile practice out there. Okay? So, thanks for listening, and I'm happy to take any questions. Thank you.
Hi. In my experience, a pair of programmers can just as equally get into a rut where they create code that is completely uninhabitable as a single programmer. In fact, sometimes a whole team of programmers can go ahead and create architecture and code that's completely uninhabitable. So, I understand your desire to skip out the review process, but how habitable is your code base as a result of that? Because pair programming, you know the groupthink principle where you have a group of people and they're all like, oh yeah, this is great, we all agree with each other, looking at each other. They're, oh yeah, they're riding that wave of coding where they're getting something done and they're committing it to the trunk and it's building and it's great, but the code's a complete, yeah? So, how do you deal with that?
Okay, I understand. So, I feel very conflicted about code reviews. I've seen it work really well in some places, I've seen it work really badly in other places. Google do trunk-based development at scale. They have 15,000 developers working on a single Perforce tree. They have 60 commits a minute at peak into trunk. And code review there is absolutely baked into their culture. They have a lot of tooling around it. It doesn't go into trunk until it's being reviewed. And it's part of your daily work and practice to review things. Yeah. I don't normally talk about Google because I don't really like to spend time talking about unicorns. I think HP is a much more relatable story than somewhere like Google, which is just crazily good. So unlike finding another company. I think the thing for me that's often missing with evolutionary architecture or people collaborating on architecture and design is that there's no vision, that's written down or drawn anywhere. So, just because we talk about minimal branching doesn't mean no branching, just because we talk about minimal planning doesn't mean no planning. For me, there's got to be some kind of shared design the team agree on up front, and we draw on a whiteboard together, and we say this is the thing that we are moving towards, and we establish different areas of the code base that are bad. We highlight the good, and we try to move everyone in that direction. So at LMAX, we had a big whiteboard, big refactorings we wanted to do. We label bits of code as evil, so if you had a few minutes, you knew so you go and find some evil code and try to get rid of it. So we were clearly showing what was bad in the code base that we didn't want to do. So that was a way, I guess, of mitigating against the need for code review, both pair programming and labeling parts of the code base that were bad. One of the guys I worked with told me that on one project they had a pirate map. So they draw out the code base as a pirate map, and they showed different parts of the code base as treasure, and different parts of it as like, all the scary things here. So that's, I guess, a different way I've not heard of. It's kind of cool, visualising your code base. So I think it can be done, but for me, there does have to be some upfront investment in understanding the direction in which you want to take the code base. Otherwise, I take your point about it can become quite belaboured, and everyone just becomes a bit.
And I just see every developer as a bit of a problem, really, especially the confident, talented ones. They go right in there and create all kinds of nightmares for you. So I like everyone to be watching.
So I think for me, trial-based development and pair programming are a good way to mitigate against individuals, regardless of confidence or talent, kind of pulling in a different direction. Because, as I said, it ensures that you work together with the maximum rate of the team. You can't go faster than anyone else in trial-based development because you can only go as fast as the person who is working the slowest or the most deliberately, if you wish. That can still happen, it can still happen with pairing, but then we're moving more into the people side of it. And trial-based development, as I said, it's very demanding in terms of people and technology.
Yeah.
Everyone has to buy into it. It's very hard. I think something we often downplay in continuous delivery and continuous integration is that this is hard.
Yeah.
Yes, Dave?
I just wanted to touch on the question about pairing. I think one of the things that allows you to mitigate the kind of the potential entrenchment that you get with pairing is to actively rotate. So having a rotation strategy so that you don't get the same people pairing over and over again. You share ideas through the team, and actually that's not a very popular idea amongst teams, but it really works, and it's certainly something that we enforced in LMAX. We would always look to be rotating people through
on a single feature or across multiple features? On a single feature?
Yeah, on a single feature.